Hello, year 8, it's Mr. Sun again, and another video for your design and technology lesson. And we're going to be moving on from what we did last time, which was all about different types of energy sources, renewable, non-renewable sources. And that gave you an understanding of where non-renewables came from. In particular, we spoke about crude oil. Now, crude oil and plastics, which is what we're going to look at, and polymers, are very, very closely linked. If you've not been into that one, if you missed that lesson and you've not had a look at it, go back on Show My Homework, or you can go to search for me, and that is Mr. Sutton DT. So you can just search Mr. Sutton DT on YouTube, as I just have, and you will see that that is my channel just there, and it's got all these videos in it, and it's also got playlists under there for loads of different subjects. If you get bored, go and knock yourself out, have a look at those, because there's loads of different ones on there. We are going to be having a look at, though, the ones that are about ecology and sustainability in the DT theory section. And within there, we're going to be looking specifically at polymers and thermoplastics and thermosetting plastics. Now, in the last lesson, we had a little bit look at renewables and non-renewables, and we discovered that non-renewables, such as gas and crude oil and also coal, are created from either plants or animals that died millions of years ago, and their bodies decomposed, were squished down really, really hard, and they turned into both gas, crude oil, and coal. Now, the crude oil one and the gas are very linked, in fact, intrinsically linked to plastics. You may not know this, but I've got my bottle here, which is made from PET. This is made from million-year-old decomposed animal bodies. That is what it's made out of. And so much, the chair I'm sat in, some of the clothes I'm wearing, the table I'm at, the computer I'm sat at, they're made out of plastics. Just about any type of plastic that you can imagine, that you can see, is made from crude oil. That's its primary source. And that's a non-renewable source material. It's something that was made millions of years ago through the formation of dead sea creatures, largely falling to the bottom of the sea, being squished down, and they turn into crude oil. And then through our clever science of human beings, we have developed the fact that we can make many different types of plastics, because there's many different types of them, from using this stuff called crude oil, this black, as they call it, black gold, in fact. Now, polymers and plastic types, we're very used to understanding about plastic. You've got plastic all around you, but a lot of you probably just think of it as just old plastic. That this PET, polyethylene, is exactly the same as on my mobile phone. I've got vinyl, polyvinyl acetate, and this type of stuff that we've got on our phone. They're different types of plastics, but they have similar roots. And this is where we come what we call polymers. They're not just called plastics, they're called polymers. And today we're going to have a look at that, what polymer actually means. Yes, a bit more science type of stuff with DT. There's a lot of links and crossovers there. But how there is two distinct families, two key types of plastics that we generally have in the world. Plastics are made from crude oil, as I've said, a natural resource. The natural resource oil cannot be replenished itself at the rate it's being used. So we know that we're using a hell of a lot of plastics. Therefore, the manufacturing of plastics is not sustainable, because so much of this type of stuff is made and then just thrown away, and we never ever use it again. And it's not sustainable. And this all links again into this environmental part, that we should be recycling this. This should be being turned into more bottles. This has been made from what they would call virgin plastic. There's no recycled parts in it. It does say on the back here that it is actually bottle and cap widely recycled, but it isn't actually made out of recycled plastic. And quite a lot of these don't end up being recycled. And we'll look at that in the next lesson next week. But one of the things I want you to look at is actually where plastic comes from. Now, many plastics, mainly thermoset plastics, end up in landfill sites and give off fumes over many decades. However, some thermoplastics can be recycled for a variety of ways and made into new products. This is called extending its life, and therefore creating a life cycle. Now, that's obviously a good thing. If we can reuse the plastic constantly, we don't have to take more crude oil that we haven't got much of, and use it again and again. And again, the plastic don't end up in the wrong place. This is the life cycle of plastics. You can see just here that it is extraction of raw materials. And in most cases, that's natural gas and crude oil. You then have the design and production. So somebody's designed the shape and it's been manufactured using a process called blow molding, where a molten plastic is blown into it. A bit like when you get chewing gum and you blow out a bubble, but it's blown out into a shape, into a mold, and it takes on the shape. Then it's packaged, so it has its label stuck on the outside. It's sent off, distribution, get used. So here I am. I've drunk a little bit of this one today. I'll continue drinking this to get my water in for the rest of the day. And then I will make sure that this goes into my recycling. Because this bit, number 5, is the key bit. Reuse and recycling. Now, if it's reused, what happens is you go back to number 2. It doesn't need to be extracted out the ground. We've already got the plastic here. This is polypropylene, this is PET. They can be separated apart, they can be melted back down. More bottles, more caps can be made out of them. So they can go round and round, round many, many times. And I could be using the same plastic, drinking from the same plastic time and time again. But if I decide I can't be bothered with this and I just fling it on the ground, as happens all too often in the world, and I see it all the time, or I don't recycle it, I don't put it in the right bin, I put it in my black bin and I just stick it out with all the other rubbish. What happens is this disposal. And as you will see in some of the videos that we will show later on in the next lesson, it means that ends up being buried in the ground and it doesn't get recycled. Eventually it will break down, but it takes tens, hundreds of thousands of years to disappear, which is not a great thing, really. Now, what is plastic? Because I said that crude oil, so the same stuff that your car is driven on, be it diesel or petrol, both of them come from crude oil. They start out life as what we call monomers. Now, monomers are little tiny molecules of the actual plastics. And for different types of processes, chemical processes, some using natural gas, some using other types of chemicals, what they do is they take these monomers, these little tiny ones, and they link them together. And you can see here we've got this black, red, and that's because they like to be attracted to different, they're opposing, a bit like magnets where you get like a positive and a negative side of a magnet and they will join together. The same happens with these wonderful things called monomers, and they are then turned into polymers. Monomer meaning one, polymer meaning many. So the great thing about plastics is they make these long chains, a bit like spaghetti, and they are then turned, as you can see in this second diagram here, into long strands. Now these long strands can then be formed together into plastics, different types of plastics depending on what monomers were started out. And the wonderful thing about these is that they can be reformed time and time again, because when we heat plastic, and you probably know this, you will often say, oh, heat plastic, it melts. Well, first of all, it becomes malleable. It actually allows you to bend and flex it. But yes, eventually it can turn into a liquid. Now, I can see this quite a lot. I have a 3D printer, and the 3D printer will use plastic and squeeze it out. It heats it up, squeezes it out, so it allows those polymers to be squeezed out, and then they cool down again and they reform into something. Fantastic. And we can do that time and time again. Now, what we have with this polymerization is we get 2 different types of plastics. Now, I have 2 videos that I'm going to be linked to this, and they're going to go into a lot more detail, and they use fantastic examples. So I'm not going to go over those in this video because they do it far, far better. And if you're not sure where to find those, dead easy. As I've said before, you can go to Mr. Sutton DT, find my playlist for ecology and sustainability. And if you come down, there's 2 of these. What is a thermosetting and thermosoftening or thermoplastic polymers? There's that video. And there's also the one that I think is even easier to understand, which is this one, which is thermosets and thermoplastics. Now, the 2 different types of plastics react differently to heat because of the way in which they have these strange cross-linking. Remember on the last one where I talked about these chains and how they're all jumbled together? These polymers. The polymer is set, Forces hold the polymers in place. Heat energy will disrupt the forces holding these polymers together, and then just like sort of spaghetti, they can all move around like that. Now this is a simpler version of it. This one at the bottom here, you can see these strands. So you've got this one linked to this one to link to this one, and we've got 3 strands here. And then these pale pink ones are what we call cross links. This is where, when it cools down, the links between the polymers, the links between the kind of strands like spaghetti, are actually held together. But the thing is, with thermoplastics, they're actually quite weak. So with a little bit of heat, something like this, if I heat it up slightly, those links break down. And that means that they will then allow themselves to slide about. So just like if you take spaghetti, if you let it cool down, it kind of all goes into a lump. Heat it up again, and it allows you to move stuff around. And the same thing happens with a thermoplastic. On the other hand, thermoset plastics, which are the other family of plastics, have much stronger cross links. This means that they have very, very strong links, and they are not affected by heat. So they are kind of heat resistant. And that means, like your plastic spatula that you use, your fish slice, and you use that in the kitchen. Well, obviously that's going to be made out of a thermoset plastic. Now, thermoset plastics, as you will see in the video, once they are molded, you can't reshape them, you can't reheat them. And this is one of their big downsides. It also links back to what I said about that whole thing about recycling stuff, the reusing of the plastic. So thermoset plastics get to this point, and they cannot, or not very easily, be remelted and changed into something else. Whereas thermoplastics, because they can be reheated and reshaped like PET, they're much more environmentally friendly. But you need to understand the difference between thermoplastics and thermosets, and it's all down to either they have strong or weak cross links. Now we've got some examples here of the different types. Thermoplastics, acrylic. Now you would have used that probably if you've done the speaker project, then you may well have used that to actually create the back of yours, or you may well have used it for other parts. Acrylic is what we would cut on the laser cutter and can easily bent up. High impact polystyrene or HIPs. Well, that type of stuff is a similar type of plastic. Things like your remote controls and things like that can be made out of it. Nylon, often created and used in clothing. Polypropylene, well, the lids on here, that's made out of polypropylene. Lots of things are made out of polypropylene. It's really good at resisting twisting forces. High density polyethylene, low density polyethylene. You got a toothpaste tube, LDP or low density polyethylene, that's really squeezy. It's got really good squeezability. So that's used for tubes. Anything in your bathroom is probably made with either high or low density polyethylene. And polyvinyl chloride, PVC. The front of my case here, my phone case, that is made out of polyvinyl chloride. It's like a kind of soft, easily malleable plastic. All of these are thermoplastics. So in other words, they can be heated up and they can have their shape changed. Thermosets, remember, once they're set, that's it. And as you will see in the videos, a bit like an egg or a pancake. Melamine formaldehyde, this disc has got a hard surface on it. That's melamine formaldehyde. Epoxy resin, if you've ever used the glue that you take 2 different types of tubes, you squeeze it together and mix it together. And the same with the polyester resin. Phenyl formaldehyde and urea formaldehyde are often used for electrical components. So the sockets on your wall, they're often made out of one or other of those, usually urea formaldehyde or phenyl formaldehyde, because it resists temperature and it's very, very strong. And all of these are what we call thermosets. And things like car engines and stuff like that will all need to be made out of these thermosetting things because they've got to withstand the heat. It's no good having an engine made out of this stuff. It'll just melt. Now, as I will come on to, and you don't need to worry too much about this in this video, but we will be moving on to this for next week. When you're recycling something, they often have a symbol on them. Now, I said that it says, well, actually, it says it's 25% recycled material. So actually, this has got 25%. So thank you very much for that, Aquavale, because 25% of that is actually made. So 25% of the plastic in this is actually recycled. Could do better than that. And this is PET. or PETE, which is number 1. So it actually has a symbol on it. I don't know if I can see it on here. It's actually on the bottom, I think, or it might be on here. Or it might be somewhere else. Somewhere printed on the plastic. Oh, there it is. It's just there on that bit, but you probably won't be able to see it because it's quite difficult and quite small. It's got this little symbol. And you've got all these different high-density polyethylene, polyvinyl chloride, low-density polyethylene, toothpaste tubes, polypropylene, just there, polystyrene, that's funny stuff that you have in packaging but also comes as a sheet. All of those 6 can be easily recycled because they are thermoplastics. And then we have other, which acrylic falls under. Now all of these can be recycled. And you can see there some examples of the different things. Have a look through those, but don't worry too much. We're going to be coming on to that next time. This time though, I want you to think about, I want you to watch those 2 videos, and I want to see if you can do these tasks. Again, it can be written down, done as a Word document, even as a PowerPoint, uploaded to Show My Homework. It's completely up to you. Number 1, I want you to draw a diagram of how the monomers in the thermoset and thermosetting plastic are arranged, adding in the cross-link parts. Now, in the video, I've already got this, so you can zoom back and have a look at that. In the PowerPoint, it's got that, but I want you to draw it down because I think often when you draw something, it goes in a little bit better. I then want you to, next to these diagrams or separately, I want you to write a paragraph explaining what both a thermosetting and a thermoplastic are. You've got 2 videos on that and everything I've said, so you should be able to talk about that and their properties. And the key properties are about heat. So think about that one. And then finally, for the third one, write 2 lists of products that use both thermosetting and thermoplastics. Have at least 3 examples. Now, this is a water bottle. I'll give you that one. This is PETE or PET, number 1 on the SPI scale. It's a thermoplastic. It can be reused. That's something in your house. Now see if you can find anything else or think about other things. The thermoplastics are going to be a tricky one. I've mentioned 2 already. See if you can come up with some others. And for those that like the extension task for achievement points, again, find examples of products which either use either type of plastic polymers and explain why they benefit from being made out of a thermosetting or a thermoplastic. If you're struggling on this and you want to do that extension task, again, I can come to your help. We've got a few more videos on here, but you can go back to my channel and have a look under playlists, and there's one just about plastics. So if you come down here, we've got all of these smart materials, papers and boards, ergonomics, and plastics. So there's a load more videos on just about plastics, and you'll see that there is loads of different things about plastics, about different processes, but there's these ones that are polystyrene, polypropylene, low density polyethylene, polyvinyl chloride, high density polyethylene, and PET, this stuff. And it will give you some uses. So if you want to do that extension task, you could pick one of these videos on there. That will help you, or just Google it. Anyway, year 8, enough from me, because you don't want to listen to me for the whole of the lesson. Hope that goes down well. Hopefully that's extended your view and you appreciate that not all plastics are made equal. They're definitely very different creatures, and there's some unusual ones out there, and we'll have a little bit more look at that as far as design is concerned next time. Keep yourself safe, look after yourself, and hope to speak to you soon. Take care.